Why did you want to be an astronaut?
So I remember thinking about being an astronaut during Apollo. Probably not Apollo 11. I was 5, I think, or 4 years old. Is that right? I was 5 years old during Apollo 11. But in those later Apollo missions, I remember thinking, boy, that would be something to be able to, fly a rocket ship into space. And then for a long period of time, I didn't think about it. It just seemed like, just completely out of the question, like other people did that. And some kid from New Jersey wouldn't have that opportunity, even though my town was next door to where Buzz Aldrin grew up. But anyway, I didn't think I'd have that opportunity. But later, once I was flying airplanes off the aircraft carrier and later decided to become a test pilot and went to graduate school, I thought, maybe somebody like me could have that opportunity. So started thinking more seriously about it, eventually applied and got selected.
Let me get you to fill in some of the details of that story. Start with your hometown. Tell me what it was like there and what it was like for you growing up there.
Yeah, so I grew up in West Orange, New Jersey, which is a suburb of New York City. At the time, I thought it was more like the suburbs, but it was actually, kind of like more of an urban suburb community, just being that close to New York and New Jersey's the most densely populated state, so it's a pretty densely populated place. Good schools, the community that, was very, very diverse. And I think it had a good influence on me growing up. My parents were local, police officers in the town, so stayed out of trouble, I think, because of that. Yeah.
So you do have a sense that there really was an influence on you from that place and those
people? Yeah,
I
think so. I think so. And when I go back there, I talk about it. I think the big influence is they had a good public school system.
Have you been able to make it out as you've flown over?
No, I've actually tried to do that. I've tried to get a good picture of West Orange, New Jersey. Just, New Jersey's just so densely populated, and it's very hard to tell one town from the next. I've taken, big pictures of the whole area, so it's in there somewhere, but I've never taken out the 400 millimeter lens and grabbed a picture where you can tell it's the town.
Tell me about the path then, from West Orange, New Jersey. What's your educational and professional path that led to astronaut?
Yeah, so after I graduated from high school at 18, I went to the U.S. Merchant Marine Academy. So I never actually lived back in New Jersey again since I was 18 years old. And that's on Long Island, New York, the United States Merchant Marine Academy. Graduated from there, went directly to flight school 4 days later. I immediately got in my car, drove to Pensacola, no vacation, and started flight school. Later, I was flying the A-6 Intruder in the Persian Gulf during Operation Desert Storm, flew 39 combat missions there. And after that, went to grad school for a couple years in Monterey, California, and then on to the U.S. Naval Test Pilot School in Patuxent River. Later, I was an instructor there, and as an instructor at TPS, the Test Pilot School, I was selected to be an astronaut and come to the Johnson Space Center in 1996, so 14 years ago.
What was it that got you interested in being in aviation and being a pilot?
So I went to a school that was focused on ships, the Merchant Marine Academy, and at the time I was really interested. And I still am. I like being on the water. I like sailing ships or power boats, and though I do remember being on a grain carrier going from Seattle to a place called Savaga, Egypt. It's in the southern part of Egypt on the Red Sea. And getting across the Pacific, that ship went 12 knots. And it took us over a month to get across the Pacific Ocean and get us to Singapore. And I thought, boy, this is way too slow. So that's when I started thinking about flying airplanes in the Navy.
And then, as you referred to a minute ago, as a test pilot, you started looking at astronaut again.
Yeah, I think a lot of test pilots do that. Being a test pilot's fun. You get to test new things and sometimes fly new airplanes. Not in my case. Well, I flew the F-18 as a test pilot, the A-6, the A-6B Prowler, but these were airplanes that were already in the fleet. Occasionally, some test pilots get to fly brand new airplanes, but we get to test new weapon systems and modifications to airplanes. And the space shuttle after STS-134 only has 134 flights. So it's kind of very, as far as when you look at number of flights go, it's still more or less in a test program, even though we've been flying it for nearly 30 years now. So it's like the ultimate test pilot job.
Well, this ultimate test pilot job is a job that we know has elements of danger to it, like some of the other jobs you've had, but an element that most people don't have in their jobs. Mark, what is it that you feel we get as a result of flying people in space that makes it worth taking that risk?
Yeah, I think people need to, each individual needs, in any job that's dangerous, you got to evaluate the risk and the reward. So for something that's really dangerous, there's got to be a pretty big, impact, and not only to me personally, like in the case of me flying the space shuttle. I look at what's the impact to, the country. I mean, what does the country get out of having the space shuttle and flying people in space? And I think it's pretty significant. Our space program, over the last 30 years has resulted in incredible advancements, for industry in the United States and for the economy. We've invented, NASA's invented, technologies that are used every day. I mean, the fact that computers don't fill up an entire room right now has a lot to do with the fact that we needed to miniaturize computer systems to be able to get, the LEM onto the surface of the moon and then back off, with very small, lightweight computers. Things like computational fluid dynamics. When we were designing the space shuttle, it's a winged vehicle, it flies into the atmosphere at Mach 25. We didn't have wind tunnels to do that. Prior to that, for any tests of any kind of airplane wing, we just stick it in a wind tunnel. Well, there aren't wind tunnels that are designed to be able to get you data at Mach 25. So we had to do it on very high-speed computers. Well, CFD, computational fluid dynamics, is now used to design anything that has flow over it. I mean, cars, pipes, surfboards, skateboards, just bicycles. It's used, it's a yearly, I think it's like a $3 billion industry. So we got that just because we decided we wanted to fly this winged vehicle into space.
Mark, you're a member of the shuttle mission STS-134 crew. Summarize the overall goals of that mission for us and tell me what your job is.
Well, I'm the commander of STS-134. We've got a whole list of mission objectives, probably 30 things on the list. But the big objectives is to get the alpha magnetic spectrometer installed on the outside of the space station. It's a premier physics experiment. It's probably the most expensive thing ever flown by the space shuttle. We also have a pallet of external spares called ELC-3 that has some spare parts. And we're going to do 4 spacewalks with really critical ISS assembly/maintenance tasks during the mission, and then a host of other things, transferring cargo, and primarily cargo transfer is a big part of it. And then we have an objective called the Storm DTO, which is a sensor for follow-on spacecraft.
It's a nice variety to keep you from getting bored.
Busy mission.
Now, almost everybody on your crew has been to the space station before. In fact, 2 of them have done long-duration missions there. Has that benefited your crew as you've been training, preparing for this flight?
Absolutely. This is the first time I've had a long-duration crew member as one of my shuttle crew members. And typically, on previous flights for a space station flow, you always have all these questions about station, where stuff is located, how the station crew would do something, what they would think. And normally you have to go and spend some time and track down that answer. But in our case, with Greg Chamitoff and Mike Fink, 2 long-duration crew members, I don't have to go very far for the answer, which has been pretty convenient for me.
Let's talk about some of the cargo that you're bringing up. You mentioned Express Logistics Carrier 3. Tell me what its function is.
Well, on the outside of the space station, we have these carriers that hold external spare parts. And we've got a number of them. And this one's ELC-3, and it's got a spare part for the SPIDM. It has some other ORUs, some other components on it that if something fails, like a pump module, which we recently had happen, so when parts like that fail, we have these ELCs positioned along the truss in a few locations, and we can take the spare parts off of there and replace them during a spacewalk.
Now, how does it get out of the payload bay and into position up on the port side of the truss?
So what we're going to do on flight day 3, right after we rendezvous, we will already have grappled ELC-3 before we rendezvous with the space station. And once we get docked and get the hatches open, one of the first things we do is we're going to pull a ELC-3 out of the payload bay, going to hand it off to the space station robotic arm, and then we're going to install it on top of on the port side of the truss.
So it's if you'll forgive the phrase, a simple robotics operation.
You know, none of them are really that simple. I mean, it's going to take 2 people on the space shuttle arm, two crew members on the space station arm, and several hours to do this complicated task of safely pulling it out of Endeavour's bay, and then handing it off to the arm, and then getting it successfully installed.
And I understand this is sort of just a plug-in, and then it's there and the work is done.
Yeah, it is. I mean, once we get it attached, it just sits there on, in standby with, different spare parts located on it, and, whether we, maybe we'll need something in a year, maybe we'll need one of those parts in 10 years. We just don't know.
The other major piece of hardware is the alpha magnetic spectrometer. Talk a bit more about what that is and what it's going to do once it's installed.
Yeah, so AMS is a $2 billion cosmic particle detector. It's got 16 partner nations, including the United States, that are involved in designing and building this instrument. It's got 60 different universities that are involved, a lot of physicists. It's managed by the Department of Energy, but the program is located in CERN in Geneva, outside of Geneva, Switzerland. And the program specifically, the principal investigator is a PhD physicist, Nobel Prize winner named Dr. Samuel Ting, who envisioned and appropriated the money and constructed AMS with a big team of engineers, but mostly physicists. And we're going to launch that as, it's pretty much our primary payload. And on flight day 5 of the mission, we'll install it on station. But AMS is a cosmic particle detector that's going to look for a bunch of different things, including antimatter, dark matter, and dark energy, stuff that we don't know a lot about. We think there's antimatter in the universe, naturally occurring. Physicists believe that at the Big Bang, there were equal parts of matter and antimatter, and we don't know where the antimatter is. So the AMS is going to try to answer a lot of those questions.
The question would always be to wonder about the significance of what it's going to do. Is understanding the origin of the universe seems relatively significant?
Yeah, absolutely. I mean, this is one of the, I think, one of the premier experiments that space station is going to have. And since we've made some modifications to AMS, it's going to be able to function all the way through 2020 and beyond, as long as the space station is in operation. And it'll collect data that whole time, and it sends, daily, it'll be sending, gigabytes, I think, gigabytes of data to the ground. That'll be analyzed initially here, and then later in CERN. They're building a big operations center just for AMS to analyze this data. And, over the course of the next 10 or 15 years, hopefully we'll answer a lot of those questions about, fundamental questions about how the universe began and what its makeup is.
It gets installed in sort of the same way that ELC does, right?
It does. So the next day, on flight day 5, with the Roberto Vittori flying the space shuttle robot arm, my Italian crew member, pull it out of the payload bay, and just like we did on flight day 4, we'll hand it off to the space station arm. But this time, AMS will be installed on the starboard side of the truss of the space station.
Once it's out there, it works just by sitting there and gathering what comes by, right?
Well, it's on. It's functioning. It's operated primarily from the ground. It's a big magnet with a magnetic field that's 2,000 times the strength of the Earth's magnetic field, I believe. Well, it's too late. You've quoted me on that. But with this magnetic field, it can detect characteristics of particles and send that info to the ground. So it can tell the difference, for instance, between a helium atom and an anti-helium atom. and it could detect whether there's antimatter flowing through it or not. And over a period of time, we expect that it'll make some pretty amazing discoveries.
Is the analysis of what it finds that's done by people on the ground
Yes.
will lead to that.
Yes, it's going to take a while to analyze that data.
No immediate answers about where's the antimatter.
I don't think we're going to turn it on and before we undock find out that we've discovered antimatter. No.
You mentioned that the plan for your flight is that your crew is going to conduct 4 spacewalks, and it's going to be done by 3 different teams of spacewalkers going outside. As the commander of the shuttle crew, what is your role going to be during the spacewalk?
Yeah, so it's not so much 3 different teams. I have 3 crew members that are going to be doing spacewalks, and there's 2 on each EVA. So for instance, Drew Foystel will do EVAs 1, 2, and 3. Mike Fink will do 2, 3, and 4, and Greg Chamitoff will do 1 and 4. So it's 3 people going outside in pairs over those 4 spacewalks. My role as the commander of Endeavour, just like I did when I was the commander of Space Shuttle Discovery for STS-124, during the EVAs, my primary role after getting them suited up and outside safely is to make sure that the EVA is conducted safely and all their tethers are correct. So I spent a lot of time actually looking out the window or on camera, zoomed in on the crew member, or in a window with binoculars, making sure that they don't, something doesn't come untethered, that there isn't like a safety hazard. So I just spent a lot of time just watching them. We have another astronaut on board who's called the task IV crew member that's kind of leading them through the spacewalk. He's got the checklist. He's telling them what's next. He's telling them the settings for the tools they have and, which connector to disconnect next. And I mean, he's doing the choreographing of the EVA, or I'm pretty much just watching to make sure we don't make a major mistake.
Give us a sense of the kinds of jobs that they're going to be performing on these 4 different spacewalks. I'm not looking for each of the 4 timelines, but what kind of work are they going to be doing out there?
Yeah, so on EVA 1, we're going to install these external science experiments, these boxes with materials and circuit boards and stuff like that. Some of the stuff is for DOE, so we're gonna bring back to the shuttle some old ones that are ready to come home to be analyzed, and we're going to reinstall some new missies on the outside of the space station. And then we're going to get some of the jumpers connected for the ammonia fill we'll do on EVA 2. And on EVA 2, we've got this big ammonia fill task that's a primary part of EVA 2, along with some other things like a Sarge lubrication. So we have to take the covers off the Sarge. We're going to lubricate it, and that's the bearing for the solar array. So we're going to lubricate one of those. And then on EVA 3, we have some tasks to do on the Russian segment, on the FGB. And fortunately, one of our crew members, Mike Fink, has done a number of Russian EVAs, so he spent a lot of time on the Russian segment. So he and Drew Foystel, my EV1, will be doing EVA 3, and he's got experience there with the Russian segment. And then in EVA 4, we're going to leave the OBSS behind. So the boom that we use to inspect the space shuttle, to make sure that there's no holes in the leading edge or no tile damage, we're going to leave that behind on space station. Presumably, I mean, right now that's the plan. It probably is not going to depend on whether there's an STS-135 or not, but we're going to leave our boom behind, so the space station will have the OBSS if it needs it in the future as an extension of the space station arm.
And you're going to put it there after you presumably are done using it?
Yes. Yeah, we'll do a late inspection on flight day 10. No, flight day
But
12.
while you're still
Yes.
docked?
Yes, while we're docked, we'll do a late inspection, and then we'll hand the boom off on flight day 10, actually.
The 3rd spacewalk, the tasks there were a relatively late addition to your timeline. What were the circumstances that led those jobs to being put onto your plate?
Well, if we add an additional shuttle flight, STS-135, which I think looks pretty likely, it's a crew of 4. They're limited by, well, a number of things. One is you have to be able to get this crew safely home somehow without a space shuttle rescue flight on standby. So they'd come home via Soyuz at a later date if there was a problem. So it needs to be a smaller crew, so it's a crew of 4, so then it's hard to do a spacewalk. So it looks like we'll be the last real shuttle crew that does spacewalks. So if we could fit it in our timeline, and we can, right now our mission's going to be 14 days, and with 4 spacewalks, since we can fit it in the timeline, there were things that we wanted to get done. And in this case for EVA-3, it's some stuff on the Russian segment.
And that got delayed because of other events that
yeah,
that
things
pushed
always
that
happen,
task.
and then they kind of roll downhill.
They rolled down. You also mentioned earlier about a storm. This is coming up during your rendezvous and docking, and again during undocking and fly around. For the DTO, storm, by the way, is sensor test for Orion relative navigation risk mitigation. And yes, I read it because I can't memorize it. But this is something new. It includes a re-rendezvous with the station. Tell me what's going on here.
Yeah, so it's the first time we'll be doing a re-rendezvous with space station, and it's a different kind of rendezvous. It's different than what we normally do with shuttles. So the plan is after we undock, we'll go out to about 400 feet. We'll do a fly around like we normally do. And then when we come up back in front of the space station again, we're then going to do these series of burns where we're going to fall behind the space station, couple 100,000 feet. And then we're going to come back in doing a profile that's actually quite similar to what Apollo used for a rendezvous. And instead of coming up on the R bar, which is right underneath the space station, or the V bar, which is the direction it's going, we're going to come up on a 45-degree angle from behind. And this sensor is what was planned to be used for Orion, and I imagine when Orion one day rendezvous and docks with the International Space Station, it'll use this storm sensor. And it's just more advanced laser system cameras that can give some very accurate range and range rate data. It's just using new technology. So we're going to test that as we come up to the space station. And we're only going to get about 600 feet away before we eventually do another burn and fall away and get ready for re-entry a couple days later.
So is the hardware for this in your payload bay, but transmitting a signal that bounce off the station?
Yeah, exactly. So the hardware sits in the forward part of the payload bay, and then we have a computer on board, and one of my crew members is going to be operating Storm from this one computer, and that's his only role. So instead of your typical 4-person team for the rendezvous, we have a 5th person that their only task during the rendezvous is to make sure Storm is functioning and goes through its correct modes, and that we're successfully gathering the data and to handle any contingencies if it's not working right.
Right up to the very last flight of Endeavour, and still doing new things.
We are.
With
well,
the shuttle.
And this is to get ready for what we're doing next.
Your flight is the last flight of Endeavour. What are your thoughts about this ship's place in the history of human spaceflight?
Well, Endeavour was the replacement for Challenger after the Challenger accident. Congress appropriated money to build to build Endeavour. At the time, the thought was, well, maybe we could modify Enterprise, which was the approach and landing test orbiter, and it was decided that to build a new one would actually be more cost-effective to build a brand new orbiter. And that became Endeavour. There was a little contest to decide how we're going to name it. But Endeavour's now been flying. I think this is going to be the 25th flight of Endeavour, the 12th to the space station. It's been, it hasn't been around as long as Discovery and Atlantis, but it's done some, pretty major things. It did the first Hubble repair mission. And since then, it's been back and forth to space station 12 times.
So it got its own little slice of the space shuttle story. But
it did. I've flown on Endeavour before, so I'm excited to fly on it again. And my brother's flown on Endeavour.
How do you feel about the shuttle's role in spaceflight history?
Well, the space shuttle was designed to build a space station. And that's why it has this big payload bay. And it never really got to do that for the first 20 years of its life. And now in the last 10, I mean, it's been critical in building ISS. Without the space shuttle, International Space Station would not be what it is today. I mean, we would not have been able to build the space station. So I think it's somewhat fitting that, you know, the end of the shuttle era is the beginning of the complete being finished with the assembly of the space station and the utilization part for the next 10 or 15 years.
Now, you're going to be flying this mission in relative proximity to a couple of significant anniversaries. On April 12th, we've got the 50th anniversary of the first human space flight, as well as the first flight of the space shuttle. And then on May 5th, the first American space flight, 50 years since Alan Shepard's first flight. What do you think about the fact that you are going to be in space around the time that people are paying attention to these kind of significant anniversaries?
Well, while we're in space, I could tell you we're probably not going to be thinking all that much about it because we're usually really busy. I do think it would be a pretty neat thing, though, if we could launch on April 12th, you know, 30 years since STS-1. You know, that would be something. You know, to reflect on, you know, the space shuttle again and what it's meant to the U.S. space program. I mean, more people have flown on the space shuttle than any other spacecraft, I mean, including Soyuz. I mean, the ability to fly 7 people into space and to have this huge payload bay and an airlock and a robotic arm and to be able to bring payloads home and land on a runway. I mean, this is the most capable spacecraft that's ever been built and probably will be built for a long period of time. And I think, you know, Americans should be proud that we've been able to build such a thing and operate it successfully for such a long period of time.
Spaceflight's changed an awful lot since Yuri Gagarin's flight to today. Mm-hmm. Where do you think we're going to be 50 years off in the future?
Yeah, so Gagarin flew 50 years ago. Today we fly routinely a space shuttle up to the space station. 50 years from now, you know, it's hard to say. It's hard to predict the future. You know, what I hope is that we, you know, like 50 years from now, like we, you know, send an orbiter up to the space station, maybe we're sending people to a base on Mars. You know, that would be pretty spectacular if we could do that. I also hope that, you know, for intercontinental travel like we do on an airplane today, then maybe it'll be spacecraft that are used to get somebody, you know, from New York to Tokyo. Instead of it being an 11 or 12-hour flight, you know, it's a 40-minute flight. You know, that would be something.